Dear enthusiastic friends, I am Nitin Shinde. Welcome to our channel Chemistry is Awesome. Our motto of learning is learn anything with understanding, interest and fun, because understanding creates interest and interest creates fun. In this lecture, we will start discussion on very important topic of organic section of 12th standard syllabus, that is halogen derivatives of hydrocarbons. In this topic, what are the points that to be discussed? Number 1, general points. In general points, first we will discuss introduction. Next, classification of halogen derivatives of hydrocarbons. Next, nomenclature of haloalkanes and haloarenes. Next, isomerism of haloalkanes and haloarenes. This is additional point. These are the points for discussion in general points. Now then we will separate haloalkanes and haloarenes. In haloalkanes, again we have to discuss 5 points. Number 1, methods of preparation of haloalkanes. Number 2, physical properties of haloalkanes. Number 3, chemical reactions or chemical properties of haloalkanes. In chemical reactions of haloalkanes, number 1, nucleophilic substitution reactions. Number 2, elimination reaction. Number 3, reaction of alkyl halides with metal like sodium or magnesium. Reaction of alkyl halides with sodium metal is called as Wurtz coupling reaction, and reaction of alkyl halide with magnesium metal is called as formation of Grignard's reagent. After chemical reactions of alkyl halides, we have to proceed for the next heading. Next point, mechanism of nucleophilic substitution reactions, SN1 and SN2 reaction mechanism, and last heading, optical isomerism in haloalkanes. So that these are the 5 points for the discussion of 5 points for our discussion in haloalkanes or alkyl halides. In haloarenes, there are only 3 points for our discussion. Number 1, again same as like alkyl halides, methods of preparation of haloarenes. Number 2, physical properties of haloarenes. Number 3, chemical reactions of haloarenes. After this discussion of haloalkanes and haloarenes, last point in this topic is uses and environmental effects of some polyhalogen derivatives of alkanes, such as methylene dichloride, chloroform, carbon tetrachloride, iodoform, etc. So that these are the total points included in very first topic of organic section. Remember, dear friends, one thing, if you learn this topic of organic section very carefully, very properly, with understanding, then you will not find any difficulty in understanding of other topics of organic section. This is the base of all organic topics. Now let us see, what is heading of this topic? Halogen derivatives of hydrocarbons. Halogen derivatives of hydrocarbons. First of all, try to understand meaning of word halogen, then hydrocarbons, and then derivatives. In 1913, Henry Moseley forwarded or put forth his periodic table. In this periodic table, total up till now 118 elements acquired their positions. This periodic table is called as Moseley's periodic table. This is also called as modern periodic table or long form of periodic table. In this periodic table, these 118 elements are arranged in 18 vertical columns called as groups and 7 horizontal rows called as periods. The elements belonging to the 17th group of the periodic table are called as halogens. The word halogen is derived from Greek roots or Greek words. HAL, hal, means salt, and gen, meaning to produce. Therefore, salt producing elements are called as halogens. This 17th group consists of 6 elements, namely fluorine, chlorine, bromine, iodine, astatine, and tenacine. Out of these 6 elements, first 4 elements, namely fluorine, chlorine, bromine, and iodine, are usually considered as halogens, while astatine and tenacine, these are short-lived radioactive elements. The group of these elements is also known as halogen family. These halogens are highly reactive, hence they does not exist free in nature. They are non-metallic and form strongly acidic compounds with hydrogen, say for example HCl, HBr, HI, HF. What is the order of acidity of these haloacids? These haloacids are also called as hydracids or halogen acids. HI is more acidic than HBr, HBr is more acidic than HCl, HCl is more acidic than HF. Because the bond length of HI is the most and bond length of HF is the least. Therefore, ionization of HI takes place easily. Since bond length is more, this bond can be easily broken or ruptured. That's why HF is weakest acid and HI is strongest acid. Why HF is weakest acid? Because bond length is shorter. Shorter is the bond, that bond is stronger and stable. That bond cannot be easily ruptured or broken. Therefore, this is order of haloacids. These haloacids on reaction with metals like sodium, potassium, calcium, magnesium form salts such as NaCl, KCl, potassium iodide, magnesium chloride, calcium chloride, etc. And therefore, sea salt producers or salt producing elements are called as halogens. This is regarding word halogen. What is next word? Hydrocarbon. Hydrocarbons are nothing but the compounds which are made up of, which are formed from hydrogen and carbon atoms only, are called as hydrocarbons. And hydrocarbon is the parent family of organic compounds, because a very large number of organic compounds are derived from hydrocarbons. Now, what do I mean by word derivatives of hydrocarbons? The compounds which are derived from hydrocarbons are called as derivatives of hydrocarbons. What do I mean by halogen derivatives of hydrocarbons? The compounds obtained by replacement of one or more hydrogen atom or atoms of an aliphatic or aromatic hydrocarbons by corresponding number of halogen atom or atoms are called halogen derivatives of hydrocarbons. We'll abbreviate this halogen derivatives of hydrocarbons like this, HDH. Just for our understanding, just for simplicity, instead of writing complete heading, in short, we can remember like this. HDH means halogen derivatives of hydrocarbons. Now this is about introduction. Now what is first and important question in this? What are halogen derivatives of hydrocarbons? How are they classified? Halogen derivatives of hydrocarbons, once again I will repeat definition. The compounds formed by replacement of one or more hydrogen atom or atoms of an aliphatic or aromatic hydrocarbons by corresponding number of halogen atom or atoms are called halogen derivatives of hydrocarbons. Here hydrocarbons may be either aliphatic or aromatic. What are aliphatic hydrocarbons? Aliphatic hydrocarbons are nothing but open chain hydrocarbons such as alkanes, alkenes, alkynes. Aliphatic compounds are also called as acyclic compounds or open chain compounds. Therefore, aliphatic hydrocarbons are nothing but open chain hydrocarbons. What are aromatic hydrocarbons? The compounds which contains one or more benzene ring in their molecule are called as aromatic compounds. And generally, aromatic compounds are characterized by their structure. They are having planar structure, conjugated double bond system, cyclic, planar, conjugated double bond, and 4n plus 2 pi electron containing system is called as aromatic system. Here we have to derive halogen derivatives from aliphatic compounds and aromatic compounds. Halogen derivatives of hydrocarbons are mainly classified in two ways. Number one, classification based on hydrocarbon skeleton to which halogen atom is bonded. This is one type of classification. And number two, classification based on number of halogen atom or atoms present in a molecule. Let's we'll start discussion on first one. Classification based on hydrocarbon skeleton to which halogen atom is bonded. According to this, halogen derivatives of hydrocarbons are classified into four subclasses. Number one, haloalkanes. Number two, haloalkenes. Number three, haloalkynes. Number four, haloarenes. Now let us see what are haloalkanes. Number one, haloalkanes. Number two, haloalkenes. Number three, haloalkynes. And number four, haloarenes. Haloalkanes are also called as alkyl halides. So that here we will write or alkyl halides. Haloalkanes are also called as alkynyl halides. Haloalkynes are also called as alkynyl halides. And haloarenes are called as aryl halides. Now, question is, what about their representations? Haloalkanes can be represented as, in short, R bond X, or they can be represented as R single bond CH2 single bond CH2 bond X. Haloalkenes or alkynyl halides can be represented like this: R single bond CH double bond CH single bond X. Alkynyl halides or haloalkynes can be represented as R single bond C triple bond C single bond X. And aryl halides can be represented drawing benzene ring or aromatic nucleus. And to this aromatic nucleus, halogen atom is directly bonded. Halogens are represented by capital X. Here capital X stands for chlorine, bromine, iodine or fluorine. Most commonly chlorine, bromine or iodine. Now let us see what are haloalkanes or alkyl halides. Statement is very simple. What is statement? To describe this haloalkanes or alkyl halides. In haloalkanes, halogen atom is bonded to a saturated carbon chain or saturated carbon skeleton. What do you mean by saturated carbon chain? A chain of carbon atoms containing carbon-carbon single bond. Chain of carbon atoms containing carbon-carbon single bonds. Such a chain of carbon atoms is called as saturated carbon chain. So that how to describe? In haloalkanes or alkyl halides, halogen atom is bonded to a saturated carbon chain. Now, what are haloalkanes? In haloalkanes, halogen atom is bonded to an unsaturated carbon chain containing carbon-carbon double bond. What is statement? In haloalkanes or alkynyl halides, halogen atom is bonded to an unsaturated carbon chain containing carbon-carbon double bond. Haloalkanes. In haloalkanes, halogen atom is bonded to an unsaturated carbon chain again containing carbon-carbon triple bond. What is unsaturated carbon chain? A chain of carbon atoms containing at least one carbon-carbon double bond or one carbon-carbon triple bond is called unsaturated carbon chain or unsaturated carbon skeleton. And what are aryl halides? In aryl halides, halogen atom is directly bonded to benzene ring or aromatic ring or aromatic nucleus. So that this is about first type of classification. But what is the important thing? You must able to write some examples also along with this description. Now what are the examples? Here in place of R we can take any alkyl group such as methyl, ethylene, propyl, isopropyl, etc. We write only two examples. CH3 single bond Br. This is first example. Name of the example is methyl followed by the name of halogen atom. While writing common name we have to put word halide. Halogen, name of halogen atom in terms of halide. Since there is bromine atom, methyl bromide. What is one more example? C2H5 single bond Cl. This compound is called as ethyl chloride or chloroethane. Now in this case we will write examples of haloalkanes. First example CH2 single bond CH2 single bond Cl. This compound is called as vinyl chloride or chloroethene. All these examples are very important. All these examples we have in practice. So that try to remember their names, both the names, common names as well as IUPAC names. Number one, vinyl chloride or chloroethene. Next example, CH3 single bond CH double bond CH single bond Cl. 1-chloropropene. This is called as 1-chloropropene since chlorine atom is bonded to carbon number first and numbering is started from this carbon atom 1, 2, 3. Since there are 3 carbon atoms containing double bond, this must be formed from propene. But at carbon number first, there is chlorine atom. Since chlorine atom is bonded to carbon number first, therefore complete name of this compound is 1-chloropropene. So this is according to IUPAC name system. What is common name of this compound? Propenyl chloride. In this format, propenyl chloride. One more example we can write CH3 single bond C bond Cl double bond CH2. This is called as isopropenyl chloride according to common name system. Since this chlorine atom is attached to secondary carbon atom, this is called as isopropenyl chloride or 2-chloropropene. So that these are the examples. This is very important example. This example we have in practice in polymers also. Therefore, try to remember examples along with their common names and IUPAC names. Now, we will write examples of haloalkanes. CH double bond triple bond C single bond Cl. This is called as ethynyl chloride. Ethynyl chloride or chloroethane. This is also called as acetylene chloride. Therefore, for this compound, we have how many names? 3 names total. 2 are common names and 1 is IUPAC name. What is first common name? Ethynyl chloride. Second common name, acetylene chloride. And what is IUPAC name? Chloroethane. ETHYNE. Now, we will write examples of haloarenes. While writing examples of haloarenes to a benzene ring, and to this benzene ring, halogen atom is directly bonded. Either you can write chlorine atom, bromine atom or iodine atom. Name of this compound is phenyl chloride. This is common name. Chlorobenzene, this is IUPAC name. So that this is about first type of classification. Very simple. Very simple classification. This classification, what is based for this classification? This classification is based on hydrocarbon skeleton to which halogen atom is bonded. According to this, there are how many subclasses? 4. Haloalkanes, haloalkenes, haloalkanes and haloarenes. Okay dear students, we'll stop here today. Thank you for watching this video. Subscribe our channel and put your suggestions in suggestion box. Thank you very much. We'll meet soon in next video.